going to be solving quadratic equations by completing the square. Our first step is going to be to rewrite the equation as x squared plus bx equals c form. So we're going to need our quadratic and our linear term on the same side. Now if your a does not equal 1, you will need to divide both sides by a. Next you find c, which means we're going to be turning x squared plus bx into a perfect square trinomial. So we need to take half of b and then square it. Then we're going to add that new c to both sides, factor the trinomial so that it's in a plus b quantity squared form, take the square root of both sides, solve for the variable, and then simplify the radical if possible. I see that number 1 is in that ax squared plus bx equals c form, and my a is 1. So I'm ready to start turning this left-hand side into a perfect square trinomial. So I'm going to take half my middle term and square it. So 8 divided by 2 squared, that'll be 4 squared, which is 16. Now that's our new c. We're going to take that c and add that to both sides. So we'll have x squared plus 8x plus 16 is equal to 9 plus 16. Now this is going to factor into a binomial squared. So what do we square to get x squared? X. What do we square to get 16? 4. Put the sign of the middle term in the middle. 9 and 16 is 25. Now we want to undo squaring, so we're going to take the square root of both sides. And when we do that, remember it's plus or minus. So that's going to leave us with x plus 4 because your exponent and root are the same. And then the square root of 25 is 5. So we're going to have two answers because x plus 4 could be positive 5 or x plus 4 could be negative 5. So on the left, we'll take away 4, and we'll get positive 1. On the right, we'll take away 4 and get negative 9. So these are our two solutions. Now, if we would have moved the 9 over, we could have factored that. There are factors of negative 9 that's going to combine to give us a positive 8. But in our next example, we'll see why completing the square is important. So this one looks a little bit different. I noticed that my a is definitely not 1, so I'm going to go ahead and divide everything through by 2, all terms, both sides, everybody. Here the 2's cancel, I get x squared. 20x divided by 2 would be 10x. Negative 12 divided by 2 is negative 6, and 0 divided by anything is 0. Okay, it looks a little better. Now we need to get our quadratic and our linear terms by themselves, so I'm going to add 6 to both sides. And that leaves me with x squared plus 10x is equal to 6. Now I have it in the right form, so I'm going to work on the 10. I'm going to divide that by 2 and square it, and that'll be 5 squared, which is 25. And then we'll add that 25 to both sides. So that'll be x squared plus 10x plus 25 is equal to 6 plus 25. Now we're going to write this as a binomial squared. What do we square to get x squared? That'll be x. Keep that middle term. What do we square to get 25? That's 5. Quantity squared. 6 and plus 25 is 31. Then we're going to undo the square by taking the square root of both sides. So that'll be x plus 5 on the left, plus or minus the square root of 31. That does not have a perfect square, so we're stuck with that. So we're going to have x plus 5 is equal to the square root of 31, or x plus 5 is equal to negative square root of 31. We're trying to get x by itself, so we take away 5. Now these are unlike. You have a rational and an irrational. Think about like terms. For like terms, they have to have the same variable, same exponent. When we talk about like radicals, they have to have the same radicand and the same root. Not the case here. So we're stuck with that. So we're going to take the rational part and park it in front. So that'll be -5 plus the square root of 31, and that's one of our answers. Over here, we'll take away 5, park that rational in front, and then minus the square root of 31. Now we could put this in our calculator and we'll get a decimal answer, but for now we're just going to leave these as exact answers. Now, what we could have done is actually move the 5 over in the beginning, subtract 5, park it in front, and then write it as plus or minus the square root of 31. Looks kind of cool, doesn't it? In number 3, I noticed that my linear term is on the wrong side. So I need to subtract 16m from both sides. And on the left, I will have m squared minus 16m. And on the right-hand side, those cancel, and I get 48. So we just subtract 16m from both sides. Now we're going to turn this into a perfect square trinomial. So we're going to use our c equals b over 2 rule, quantity squared. So that'll be b is -2, divide that by 2 and square it. So that will be -8 squared, which is positive 64. So we're going to need to add 64 to both sides. So that'll be m squared minus 16m plus 64 is equal to 48 plus 64. I'm going to write this as a binomial squared. The way to get m squared is to square m. Take that middle sign, and what do we square to get 64? That would be 8. And that perfect square trinomial does factor into a binomial squared. If we actually multiplied m minus 8 times m minus 8, we would see that these are the 3 terms we would get after we simplified. Okay, so 48 plus 64 is going to give us 112. We're going to take the square root of both sides, plus or minus. M minus 8 falls out. And there is a perfect square that goes 100 into 112, but you might not see it right off. So at this step, I'm going to go ahead and simplify my radical. And I'm going to do that using the factor tree method. And I always start with the smallest number that goes into it. You don't have to, but this keeps your factors in order. Okay, and then 2 does go into 56 28 times, 2 goes into 28 14, and 2 goes into 14 7 times. So since we're doing square roots, group these in 2's. And then we can rewrite this as 2 squared times 2 squared times 7. Okay, so we were finding the square root of 112 and we just rewrote it this way. Okay, we know by the product property we can take these apart. And this is a good idea if you get confused about what stays under the radical. Okay, so the square root of 2 squared, when your exponent and root are the same, that just falls out. So that's going to be 2. Because if you think about it another way, the square root of 4 is 2. Same thing here, square root of 4 is 2. Square root of 7 is a decimal, so he has to stay under the radical. And then 2 times 2 is 4. So we've got 4 square root of 7, and that's the same thing as the square root of 112. So we're going to replace the square root of 112 with 4 square root of 7. So here we have 2 possible answers. We could have m minus 8 is equal to positive 4 square root of 7, or m minus 8 is equal to negative 4 square root of 7. And that gives us our 2 little equations. Here we'll add 8 to both sides. We can't add rationals to irrationals. We're just stuck with this. Boom, that's it for that answer. Over here, add 8. And it'll be 8 minus 4 square root of 7. That's all you can do to that problem. Okay, but we can write it a shorter way. We could have just taken this way up here and added 8 and parked the 8 in front, and that would be 8 plus or minus 4 square root of 7. And that's completing the square. Have a great day.